Very good morning, my dear students. Today we are going to start a very simple topic that is based on class 12. Actually, you have studied in the class 10. That is nothing, it is sign convention of spherical mirror. Sign convention. Sign convention of spherical mirror. Sign convention for spherical mirror. Headline W. It is very simple topic but very important. Sign convention of spherical mirror. So we have well familiar with the spherical mirror. What is spherical mirror? What type of image it form? Okay, so this all thing we have discussed. And this topic you have studied in the class 10, but I am going to repeat this thing in class 12 so that it become easier for you in the next derivations, whatever we'll do in this particular chapter. So what is exactly sign convention of a spherical mirror refers? Sign convention is nothing but it is a set of rules. It is a set of rules. You can say it is a set of rules. Set of rules we follow when we study about the reflection of spherical mirror or about the reflection in spherical mirror. Again I am repeating, sign convention of spherical mirror is nothing but it is a set of some rules that we follow when we study about the reflection of light, in particularly spherical mirror. Okay, spherical, when I say spherical mirrors, you will understand that we are going to talk about both concave and convex mirror. Fine. So headline you should note it down, sign convention of spherical mirror. If I consider a spherical mirror, let me consider a concave mirror. I told you what type of mirror this is. This is a concave mirror. So this part, this is some layer of this particular mirror, or this part is also silvered, okay, by some materials, and this will be your reflecting surfaces where the image will be formed. So if I make, so this will be its principal axis. This is its principal axis. This is called the principal axis of a spherical mirror. We found this is called the pole of the mirror. This is principal focus of the mirror, and somewhere here this will be the center of curvature of the mirror. So in this case, in this particular situation of condition of sign convention of spherical mirror, all the distance will be measured from the pole of the mirror. Remember, first point note down. All the distance will be measured from the pole of the mirror. In this case, this pole will be considered as origin. Pole will be considered as origin of this particular coordinate system, and this principal axis, if I write this is principal axis will be behave as x-axis. Okay, this is very important point. You note it down. In this particular system of sign convention, in case of spherical mirror, the pole will behave as origin. We will consider this as origin, and this principal axis will be behave as x-axis, like we found in the coordinate system. X, it is y, it is on the string. Okay. So as I told you, all the distances will be measured from the pole. maybe towards the left side, maybe towards the right side. So this will be left side of the mirror. This side will be what? Left side of the mirror. This side will be right side of the mirror. So any distance measured towards the right side of the mirror is positive. Okay? Any distance towards the right side of the mirror is considered as positive. That means any distance from the pole towards this side will be regarded as positive. Okay? Any distances measured left of this particular pole will be considered as negative. Is that clear to all of you? Any distances measured right side of the mirror will be positive. Any distances measured left side of the mirror will be negative. Okay? Any distance above the principal axis, will be positive. So if I consider any distance above the principal axis, say any distance above the principal axis. So above the principal axis means positive, and any distance below the principal axis will be negative. Understand? So this is most important thing. Again, I am repeating you that all the distance will be measured from the pole of the mirror. Any distance you measure right side of the mirror will be positive. Any distance you measure left side of the mirror will be negative. Any distance you measure above the principal axis will be positive. Any distance, and any distance you measure below the principal axis will be your negative. Understand? Okay, so right side and above side is positive, left side and below is negative. Remember, okay, this is shortly the basic rules of sign convention in case of spherical mirror. Now we'll try to find out in case of image, in case of object, whether they will be positive or negative. So if I consider this is a concave mirror, no matter whether it is concave or convex mirror. See, if I consider this is a convex mirror, say this is a convex mirror, this will be the layered portion and this will be the reflecting surface, and here we go, and this is your principal axis. Now in this situation, this is going to be pole, this is going to be principal focus, this is going to be your center of gravity. Now this is concave and this is convex, but in case of both mirror, the reflecting surface is toward left side. That means no doubt the image object will be kept towards the left side, and here also I will keep the object where towards the left side. So as we found that object distance is expressed as u. Object distance is expressed as u. So object distance for both concave and convex mirror will be negative. Understand? Object distance will be negative for both concave and convex mirror. Why? Because always we keep the object towards the left side of the mirror, and any distances measured towards the left side of the mirror are considered as negative distance. Okay, so if I consider, suppose this is your AB is an object, and suppose this is also AB. Now if I form the images here, suppose like that it is coming, and after reflection how it will go? It will pass like that. Suppose like that will pass. Okay, If I keep one more object here similarly, so they will be going like that, and after reflection they are meeting in this particular point. Now object, in this case object will be AB, and this will be the direction. After reflection they will meet in this particular point. Okay, so this will be the images of the object AB in case of concave mirror. As I told you, that object distance is expressed as U, and this is going to be negative for both concave and convex mirror. But in case of, now what will be the, as this is object image, so image distance is expressed as P. So what will be the image distance in case of concave mirror? You see where the image is forming. Image is forming where? Towards the left side. That means the image distance will also be negative for concave mirror. Okay? But in some case, the image also formed behind the mirror in case of concave mirror. Then it will be your positive. Understand now? So object distance and image distance for a concave mirror is going to be negative. So if you consider this is your P, this is EP, this is C, this is what? Radius of curvature. This much of distance you can consider. This is what? This is your radius of curvature. Radius of curvature is also which side? Towards the left side. So radius of curvature will also be negative for concave mirror. Similarly, this is your focal length. Focal length is also going to be negative in case of concave mirror. So we can find in case of concave mirror maximum things are negative because they are forming left side of the mirror. If you see in case of a convex mirror, suppose this is the convex mirror and images are going to form like that. It is AB will be a little bit larger. This will be the AB object, and they are going in such fashion. Just watch this diagram how I am drawing. Okay, so they will be diverse. As I told you that this type of mirror is known as diverging mirror. Okay, this will be the direction, and if I give some breaking line, what does it will mean? It will mean that these rays are appear to meet in this particular point. Appear to meet, this all thing I have told you. Now in this case, this is AB. Image is forming which side? Image is forming right side of the mirror. So in this case, this is for what? This is for concave mirror. This is for concave. This is for concave. One more time, I will explain after telling these things. So this is your object distance. Object which side? Object is left side, so object will be negative. Why? Because it is already left side. Where image is forming, this is the image. So image distance will be your positive. Okay? Image distance will be positive. This is going to be your focal length, and this is going to be your radius of curvature. So focal length F is going to be what? Positive. Why? Because it is right side of the mirror, and radius of curvature is also going to be positive. This is in case of convex. This is in case of convex. So understand that? So what is you should understand that any distance left side of the mirror is negative. Any distance right of the mirror is positive. Any distance above the principal axis is positive, and any distance below the principal axis is negative. Okay, and this is for concave and convex. I have given separately. You practice at home. One more thing: height of the object. Height of the object will be this is height of the object. If the height of the object is above the principal axis, it will be positive. And if the height of the image is above the principal axis, will be positive. If the height of the image is below the principal axis, it will be your negative. Okay, so these are very simple thing. You can study, you practice this diagram, it will be very easy for you. That's all for the sign convention. Thank you so much.